right, let's take a look at chapter 8, problem number 10. This is the Center for Disease Control and Prevention defines a healthy sleep duration as at least 7 hours. CDC reports the percentage of people who report a healthy sleep duration varies by marital status. Surprise, surprise. CDC also reports in 2018, 67% of those who are married report healthy sleep. 62% of those who have never been married report healthy sleep, and 56% of those who are divorced, widowed, or separated report healthy sleep. The file Sleep Habits contains sample data on the sleeping habits of people who have never been married that are consistent with the CDC's findings. Use the data to answer the following questions. So we'll click on the data file here, and we'll download it. All right. All right. So the problem with this, if I'm remembering this problem right, is that this data set's huge, like over 6,000, maybe like 7,000 data points, which is cool, but also makes kind of a pain in the butt for us. So the first thing it wants us to do is develop a point estimate and add a 95% confidence interval for the proportion of those who have never been married who report a healthy sleep duration. So remember, all of this data is people who've never been married. So what we have to do is just get a count. And so there's more than one way to do this. I'm going to just go here and I'm going to, let's see, make this full screen for a minute. We'll sort and filter it. And I'm just going to sort it smallest to largest. And so I'm going to go ahead and say unhealthy, which means people under 7 hours, and healthy, which means people over 7 hours. And there's more than one way to do this, but I'm just going to grab here and I'm going to highlight till I get down to 6.9. So, or actually till I see 7. All right. Ooh, I went too fast. All right. Somewhere in here, we'll get there it is. All right. So if I let go right there, I'll see if I look over here at the count, it'll tell me that there are 2,607 cells selected. So the number of people who are reporting 6.9 hours or fewer is 2,607. I'm going to just put that right here, 2,607 people. And then I'll go down to where 7 started. So many. And I'll start on that 7, and I'll go down and highlight to the end of the data set. Like I said, probably there's a faster way for people who care to do it. And my count is 4,437. All right, so my total sample size, which I'm going to label N, is just my unhealthy plus my healthy. So there were 7,044 people in this sample, 2,607 reported sleep of under 7 hours, and 4,437 reported sleep of greater than 7 hours. So to find our P, or our percentage, or our proportion is the right term, P bar, actually, we're going to go ahead and take the healthy sleepers divided by the total. And that's going to give us 0.6299. So our point estimate is 0.6299. And then we're just going to do a confidence interval. So what else are we going to need to do that? Well, we're going to need, if we have our proportion, our sample proportion, and our sample size, we're also going to need our z-score of alpha divided by 2. My confidence is 0.95, which means my alpha is 1 minus my confidence. And yeah, I know I could just do this with skipping all that, but I just like to get in the habit of doing it. And then my z-score of alpha divided by 2 equals the absolute value of norm.s.inv of my alpha divided by 2. All right. So now to find our margin of error, all I have to do is take my z-score of alpha, whoops, I have to do equals first. My z-score of alpha divided by 2 times the square root of p times 1 minus p divided by n. And that should be our margin of error. So then to find our confidence interval, we're just going to say the lower end of that is p minus the margin of error. And the upper end of that is p, oops, I have to do an equals, p plus the margin of error. I think it wants us to do it to 4 decimals. So we'll let Excel do the work for us. And we'll say 0.6186 and 0.6412. So we're 95% confident that the population proportion is somewhere between 0.6186 and 0.6412. Okay, we can go ahead and check our work. Don't be afraid to use those checks. So we're good on those. So now it wants us to develop a point estimate and a 95% confidence interval for the mean number of hours of sleep for those who have never been married. So here we dealt with a proportion. When we want to figure out the number of hours of sleep, we'll be dealing with a value of X, right? So to do that, we're going to need our mean and our standard deviation. Now remember, this is a sample. So this is going to be a standard deviation, or I should say a sample standard deviation, because we don't know the population standard deviation. All right, so then find the mean, we'll just do average. And so we don't have to highlight this whole thing. I'll show you kind of a trick. We can just, whoops. We can look up here. Okay, I'm having problems now, sorry. Okay, we can look up here. Ooh, maybe we can't do that. Okay, never mind. So I won't show you a trick. So equals average. And now we're just going to highlight every single one of these values. It'll take a second. That's what's a little bit of a pain. Almost there. See, it takes forever, huh? All right, there it is. So that gives us our average. It wants 4 decimals. So we're going to actually take it out to 4 decimals. And then our sample standard deviation. I like that better. Here's the trick I was talking about. I know that this is the interval now, or not the interval, but it's the number that we want the average for. So I can just do equals stdev. I mean, sorry, stdev dot s. And then I can paste in that A2 to A7045, which is what we just did for the mean as well. So there's our sample standard deviation. All right, so Our point estimate is just going to be this average, 0.72257. Whoops. 2257. Okay, that's right. So to find my confidence interval, I'm going to have to find my margin of error. Here's my problem. I can't use my z of alpha divided by 2 up here because I have a sample standard deviation and not a population standard deviation. I'm going to have to use my t distribution. So I'm going to need my t of alpha divided by 2. So this is going to be the absolute value of t dot inv, where my probability is alpha divided by 2. And then my degrees of freedom is n minus 1. We're going to find that our t of alpha divided by 2 is going to be pretty close to our z of alpha divided by 2. Really close, right? And that's primarily because we have a huge data set here, right? The higher n goes, the closer the t-score and the z-score will come in line with each other. All right, so our margin of error then is just going to be our t-score of alpha divided by 2 times the standard deviation, sample standard deviation, divided by the square root of n. So it is that one times our sample standard deviation divided by square root of n. There's our margin of error. And so now our lower is going to be our mean minus our margin of error. And our upper may be our mean plus our margin of error. Oh, I thought that was weird. 7.2257. Okay, confidence interval 7.2065 and 7.2449. So we can see there that that's a pretty darn good confidence interval. That's right. We are 95% confident that the true average, okay, of the population is between 7.20 and 7.25. So that's pretty good. We're going to say we're pretty sure people get about 7.2 hours in that data set. All right. So the last one says, for those who have never been married, estimate the number of hours of sleep per day for those who report a healthy sleep duration. So really that just means we're going to find the average of those who have 7+ hours of sleep, right? So I'm going to say equals average, if I can spell it. Then I'm going to scroll down until I get to the 7s. And then I'm going to drag that all the way to the end. And that's going to give us 7.7. Again, we're going to take it out to 4 decimals, 7.7293. And that should be it. All right. Well, I hope that was helpful to you. And as always, don't be afraid to reach out if you need more help.